as you can see, I have 10 cards on the table. I'm going to go ahead and just toss them kind of randomly into the air, flipping them face up, face down in some fashion. Okay, and I'll just mix these together. Now what I'm going to do is I'm going to actually show you what it is I'm doing. And in some ways, even seeing what I'm doing takes very little from the wonder of this card principle that we'll talk about today. Okay, so I'm going to take these cards under the table, under this table here, but not really. You're going to quote, see under the table. You'll see what I'm doing under the table. I'm going to tell the spectator that after years of training, I've been able to sense the difference between an up-facing card and a down-facing card. So I'm going to separate these 10 cards into 2 piles that have the exact same number of up-facing cards. Okay, so let's see if I've lost my touch. Now, under the table, this is all I will do. I will count off quietly to myself 5 cards. So push off 1, 2, 3, 4, 5, flip. I'm now ready to bring them out from underneath the table, put them on the table, and tell the spectator, let's see if I've lost my edge. Was I able to divide these 10 cards into 2 piles with exactly the same number of up-facing cards? I did indeed. 2 up-facing here and 2 there. Now the spectator will probably say, well, do it again. There's no way that you could do that, right? So you could actually throw it up into the air again, or just start from here if you would like. So why don't we go ahead, we'll throw it up again, and I think you'll be able to begin to see at least the mechanics of what's going on, but not necessarily why this is happening. Okay, so you just kind of flip these face up, face down, however you like. Okay, kind of bent that one. Sorry about that. Okay, and then you gather these up. Okay, and I don't know if you noticed something special about the number of up-facing and down-facing cards. And then you tell the spectator, okay, well, I'll try to do the same thing again. I'm looking to divide these cards into 2 halves that have the same number of up-facing cards. You take them under the table. Now this time I'm going to count off 4. 1, 2, 3, 4, flip. Bring these out. Confirm to all the world that you are a card wizard. I have 3 facing up in each pile. Okay, well, what in the world is going on with this principle? And this truly is like the simplest application of this principle. And the principle in question is called the face-up cards principle. Now, this principle can be used in so many creative ways and be the engine driving so many amazing effects. It really is quite staggering. So if you rewind the video, you'll be able to pick up on the procedure that I went through. And then in just a minute or two, we're going to go through and explain why it's true. Okay, so the first one I did, I flipped it up like this. I dropped the cards randomly, and it really was meant to be random. Now, it ended up in the first example I showed you, there were 5 up-facing cards. So you can just gather these. Now, you can have the spectator do all of this flipping, by the way. They can flip as much as they want. Though it is important for you to see how many cards are face up. Okay, that's the only information you actually need in this particular application of this principle. You gather these, and then you tell them the story of how you're able to detect the difference between an up-facing and down-facing card, and you're going to amazingly separate these cards into two piles that have the same number of up-facing cards. Now, I need to point out that that should be quite surprising because there were 5 face-up cards. Well, 5 is not divisible by 2. So you can't separate these as is without flipping over cards into 2 piles where each pile has the same number of face-up cards because 5 is odd, okay? So it should strike them as kind of unusual. How are you doing this? But if you caught it, all I did was, because there were 5 up-facing cards under the table, I just quietly counted off 5 cards, 3, 4, 5. Now it is true that if the number of cards face up is half of the packet size, which is true here, I have 10 cards, half of them were face up at the start, it actually doesn't matter which one you flip. Okay, that's kind of interesting and can be important in some other applications. But the safest thing to do is the number of cards that you've counted off, which needs to match the number of original up-facing cards. You flip that half, that portion, I should say, that portion. And now these 2 halves are guaranteed to have exactly the same number of up-facing cards. Okay. In the second example, do you remember how many cards were up-facing after we kind of dropped them randomly and made a big mess? I believe it was 4. Wasn't it 4? You can go back and check. So we had 4 cards that were face up. Okay. So I need one more. Whoops. So we have 4 now, and then so you can gather. The amazing thing, these can be gathered in any particular order. There's nothing special about how these are being arranged among themselves. It truly is just a random arrangement of the cards here. And the only thing you know and the only thing you need to know is that there are 4 up-facing cards. You don't need to know where they are or what they are, okay? And so you would now take the packet under the table, quietly count off 1, 2, 3, 4, flip, and then bring them out and show the whole world that you have not lost your magical touch. Now, before we look at, quote, the proof of this, I wanted to show you, now this particular application is about as simple as they come. This is probably like a beginner's use of this principle. A more advanced use I thought I would show you because it really is just amazing to watch this happen. Okay, and it's not too hard to master this. It really isn't, okay? So I'm going to show you kind of a routine, and if you'll practice this, it's very likely you'll never forget this procedure and be able to do it for anyone at any time. Now, I'm going to go ahead and just work with 10 cards here as well. And in this chart here, I have 0s and 1s. A 0 indicates don't flip that card. A 1 indicates go ahead and flip it over, okay, from whatever orientation it has at that moment, okay? And then I say top 5, bottom 5, okay? So the first thing that we do need is you need 5 up-facing cards and 5 down, okay? So it's like the very first example that we did. Okay. So here, how you would kind of do this. I don't have to have exactly those, but the idea is you start with. Let's start at the beginning here. You start with 10 down facing cards. Okay, and then you tell the spectator, okay, we're going to flip half of these face up. Okay. And then you can have them just mix these to their heart's content. They can mix these however they like. Okay, they truly can. Okay, and once they're happy with the mixing of the cards, they just hand them to you. And now what you're going to do, and you can do this, and I always do it with my eyes closed. Now, you do need to have in mind a couple of simple sequences. The first one is right here, 0, 0, 1, 0, 0 for the top 5 cards. That just means don't flip the top one or the second one, flip the third, don't flip the fourth or fifth. That's all that means. And that would be our, quote, first sweep through this packet of 10. The other sequence is 0, 1, 1, 1, 0, which means you set down that top card, don't flip it. The next 3 are flipped individually, and then the final one is not flipped. Okay? So why don't we go to that point really quickly here. So I would take this packet in which they've kind of randomly, doesn't look very randomly mixed up there, but randomly mixed in the up-facing and down-facing cards. And now with my eyes closed, now some people find it easier, instead of using zeros, you might use a letter D. So D for down. And then instead of a 1, you can use the letter F for flip. So this would be like down, down, flip, down, down. For the bottom half, it's going to be down, flip, 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 down. Okay, so if that's an easier way for you to remember it, that's great. I think eventually you'll find that the zeros and ones are actually a less complicated way of picturing what it is you need to do. Just picturing those zeros and ones. Now, it is important here, and I want to point this out because it'll help you remember them. There is some symmetry here, and it's needed. It's very helpful to have this. So we're focused on the first sweep through the packet of 10. Okay, so I have a 0, 0, 1, 0, 0. Well, this sequence is palindromic, right? So that means you can read it from either direction, and it reads the same way, right? 0, 0, 1, 0, 0, 0, 0, 1, 0, 0. Okay, so that symmetry is really helpful. The same thing here. This particular list of zeros and ones was chosen partly because of its symmetry of the zeros on either end, but also because it's different from this one here. Okay, so it's going to give the impression of just random actions being performed that lead to a very surprising outcome. Okay, so the first sweep through the top 5 will be essentially a down, down, flip, down, down. And then when you get to the bottom 5, it's going to be down, flip, 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 down. Okay, so let's go ahead and I'll just kind of show you that. So think of the top 5 cards here. There they are, top 5. Stops at the 10. So I'm going to, and you can do this with your eyes closed. So down, and now you wouldn't say this out loud. Down, down, flip, down, down. Now I'm over here. Down, flip, 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 down. Now what you can do is like hesitate a little bit between each of those actions, or even when you're dealing them down sequentially, to make it out as if you're kind of pondering or you're receiving signals from the beyond or something, right? Okay, so we've gone through this packet of 10 once, performing these actions here. And in particular, the third card's been flipped from what it was, and then 4th, 5th left the same, 6th left the same, 7th, 8th, 9th have been flipped from their their current orientation before doing the flipping, and then the last one goes down as is. So now what you do is you sweep through a second time, and then that will separate them perfectly, and it will truly make you look like a wizard, because during all of it, your eyes are tightly closed. You're not seeing anything, okay? In fact, though, some people will be watching your eyes. Is he peeking? No, I don't think so. But yet you're able to accomplish what we need to here, okay? So we've done the first sweep through the top 5 and bottom 5, okay? So we're coming back over here. Now, what's really nice about the second sweep for the top 5, well, look, it's exactly the same actions, okay? Well, think about that. What will that do to the original top 5? What did we do to the top 5 at first? We did a down, down, flip, down, down. And now we're going to perform the same down, down, flip, down, down. So in the end, the original top 5 will be returned to their original state. So it's like dividing the cards in half into a group of 5 and 5, leaving one group of 5 as is, kind of like I did where I divided it into 2 groups of 5. I flipped one group of 5, but I didn't flip the other, right? So one group of 5 was left alone. Well, the top 5 cards are going to be the cards left alone, okay? Now that's different than what's going to happen for the bottom 5. Sorry, I need to be over here. For the second sweep of the bottom 5, look at the actions we're performing. What's been done to the bottom 5 cards already? First one was just set down, then flip, flip, flip down. Okay, so the middle 3 have been flipped from their original orientation. Now when we sweep through the packet one more time, the middle 3 that were flipped will be left as they are, so they're still flipped. And then the last one, which was left alone originally, will now be flipped. So the net effect of all of these actions on the bottom 5 is each and every one of those cards in the bottom half will be flipped from the orientation they were in right before they were handed to you to work with. Okay? And whereas the net effect here is to return it to its original state. Okay? So that's kind of the big picture here. Now we've gone through once, right? I went through and did this, and then I did this. Okay? Now think about it. Where do I need to go next? What cards are sitting on top? Is it the top 5 cards on top again? Or is it the bottom 5 cards on top? So just think for a second. Because when we dealt out the top 5, they go to the bottom. And then I dealt out the original bottom on top of those. So technically the top 5 cards here were at the bottom of the original packet of 10. So that means what I need to do is I'm essentially going to now not undo, I'm going to clean up here so that all of these are quote ones, so that all of the cards that were originally in the bottom half are flipped from their original orientation. Okay, and that's where the second sweep comes in. Okay, so this one was not flipped over the first time through. Okay, but now I do. So I go flip and then down, 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 and then flip. Okay, so that can be one pile. And now I'm looking, I have the original top 5 cards in my hand. That's what these are. And if you remember, we just performed the same actions on those because they, in some sense, cancel each other out. If you flip a card twice, you return it to its original orientation. So here I just do down, down, flip, down, down. So doing those actions will guarantee that you'll have the same number of face-up cards in each half. Sorry, going off the camera. And we do. We have 2. Okay. Now, at first, that might look kind of complicated, and you might think, there's no way I could ever master that. That really is not true. It does not take much time to master this, and the sequences here are constructed in such a way that with the symmetry they have, and let me just give you my rationale for, you might think, why these sequences? And you may come up with your own system for accomplishing what we're accomplishing here. That's the important thing. And if you want to do that, that's great. Let me explain my rationale for choosing these, because I think it'll help you remember them. I thought, okay, for the top 5 cards, well, why don't I flip over the minimum number possible, but at the same time flip over something, right? So I thought, okay, I'll do a down, down, flip, and then down, down, because of symmetry, we want that. And then for the bottom half, I thought, okay, what's the most number of flips I can do with the symmetry requirement and not flip over all of them? If you flip over all of them, that looks kind of silly, right? So I thought, oh, okay, just do down and then flip, 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 and then down, okay? So that's the reason I came up with these sequences. And another way of looking at this is I have as many zeros as I can have here while still flipping at least one card, and here it's one card. And now, going from here to here, what I did was I just decreased the number of cards just being dealt down by 2. So I changed this 0 to a 1, this 0 to a 1, and that's how I arrived at this sequence here, in which we are flipping as many as we can without flipping all of them, but maintaining a symmetry where you can read the sequence in any order. And can you see why that's important? Because when you deal things down, it reverses their position, the position of the cards. So if you actually label this card 1, 2, 3, 4, 5, when you deal it down, the card 1 will be at the bottom of that group of 5. It'll be 1, 2, 3, 4, 5 in reverse. Well, because of the symmetry of the procedure we're using, we don't even have to worry about that. You don't even stress. That's the key. These sequences were chosen to prevent the complexity of the whole thing spinning out of control. Okay, so it's meant to keep things as simple as possible. Okay, so let's go through this, in some ways, beginner level procedure for doing what I'm suggesting here, and then we'll ramp up the sophistication a little bit. Okay, so let's go ahead. So where you need to start for this effect is you just have the spectator kind of randomly mixed together 5 up facing and 5 down facing cards. Okay, and then you tell them, okay, you're going to use now here you'd probably say you're going to use your intuition or something. You're not necessarily feeling the cards like you claim you did under the table or something. You're just going to close your eyes and just say, after years of training, I've been able to use my intuition to divide a packet of cards, such as this one, into 2 equal piles, where each pile has the same number of up-facing cards. It's like kind of bringing balance to the force. Now with your eyes closed, so if you can just kind of picture these sequences here. So first sweep, I'm going, and I normally do it in hand, by the way. So I go let's see, let's move this, I'm going to move this down here so that you can see the digits. So I go like down, down, flip, down, down, first sweep through the top 5, now the bottom 5, and then I go down, flip, 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 down. Okay, and you don't have to flip it that same way. You could do it to the table if you'd like. I'm just showing that you can also do it in hand, which is kind of fun. And now for the second sweep, it's probably good to do it to the table. Now you have to remember, where are we? So what are the cards on top? Well, it's the original bottom 5. And what have we done to the original bottom 5? We've done this. We did a down, flip, 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 down. Well, we want to complete the action of flipping over all of them. Okay, so that first one that we put down needs to be flipped. The middle 3 are flipped, or we flipped them, I should say. And then the last one needs to be flipped. Okay, and so here I would just go flip. So over here, flip, down, 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 flip. So this one's ready. Now I'm looking at the original top 5. Well, what's great is you just perform the same actions, because we're wanting to bring those cards back to original state. So just down, down, flip, down, down. And I assure you that when you're doing all of this down and flipping, it will look utterly random to the spectator. It really will. Because you're doing something different here than you did here, and then these are some distance apart in terms of the procedure that you're doing the same thing there. So really no one catches on to that. And then you kind of slowly reveal, were you able to use your intuition to divide those evenly into 2 piles with the same number of up-facing cards? You were indeed. Okay. Now I do also want to point out that if you take either one of these, flip it and set it on top, you're actually back to where you were in the sense of 5 up facing and 5 down facing. So that's kind of a helpful thing to realize, because spectator may not pick up on that, and so you can actually just flip either one and say, well, let's try that again, so that you don't have to have them choose 5 up facing, 5 and mix them and all that. You just immediately go on to doing it a second time or whatever. Now, let's look at a more advanced use of all this. Because for somebody to do it exactly the same way every time, and normally it's not good to repeat card tricks generally, but this one can be repeated as many times as you like because you seemingly change the method every single time. Okay, let me show you what I mean. Okay, so now what you can do is we're going to do our first sweep. Now think about it. Right now, the top 5 just happen to be the top 5. I mean, if we had mixed it differently, it'd be on the bottom or mixed with the bottom, interlaced in some way. So it's really not important for the first sweep that it technically comes from exactly the top 5 and the bottom 5. That doesn't matter. Now, once you've done the first sweep, then you do have to be careful with your second sweep, because your second sweep is going to go through and like straighten things out. Okay. So what I'm saying here is instead of just, taking from the top, so maybe I'll do down, and then from the bottom, I'll put that one down, and then maybe this one will be the flipped one. Maybe down here, and then this one down, okay? So essentially, we took 5 of the cards and performed this action here, okay? A similar thing over here. I could take, this could be my first down, this could be my first flip, and then this could be my next flip, this could be my third flip, and then just put that one down, okay? So in terms of the first sweep through a packet, we do have a packet of 10 cards where there's like a top and bottom half that have had these different actions performed on them, okay? Now, for the second sweep, you need to be a little more careful because the fact is, remember, the top 5 are the ones that we went through this procedure, the latter half of the first sweep with, right? So we're needing to do this. We're needing to flip the top one. The next 3 need to be just set down, and then the 5th one needs to be flipped, okay? So do that. So you just say down, and then, flip, down, 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 flip, okay? And then over here, we're doing the same thing. Now, you can be clever about it, too, because you can go down. That's that one. How about the one on the bottom? It's a down, down. How about the next one on top? It's a down. What about this one? You flip it, and then that one goes down. So you can draw from the top and bottom however you like in a very haphazard way, actually, but still be true to performing the very operations on the packet that are needed to divide it into 2 piles where you have exactly the same number of up-facing cards in each pile. Okay. So anyway, I hope that makes sense. I know it's getting probably a little bit complicated. Why don't we just do one more of this more advanced, and maybe I'll even give you a couple of other suggestions. And then let's take why is this crazy principle true? Okay. And I've looked online, and honestly, I have never found a correct proof. There's so many bogus proofs of this result. It's really kind of discouraging. There's so many wrong ways of arguing why this works. Okay, and I've actually collected a whole bunch of them just out of interest, but we'll show you a correct proof for it. Okay, so here in this particular situation with 10 cards, we've chosen kind of this system here. You can come up with your own system. Okay, so we're going to do our first sweep. It doesn't actually matter where you draw from. In fact, you could get really sneaky. You can go down, down, flip, down, down. That would work just fine. And then over here you go like down, flip, 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 down. Okay, so that will work, just fine. I guess I was supposed to put them on top of that one, but it doesn't matter. Okay, so just remember this is the bottom. Okay, but now you're a bit more constrained, right? So this one needs to be flipped from what it was. these three go down as they were, as you just left them. This one needs to be flipped. And then over here, second sweeps, down, down, flip, down, down. And then as long as I haven't made a mistake, we should have the same number of up-facing cards in each, and we do, it's 3. Okay. So anyway, so once you get the idea of this principle and this particular procedure down, you can come up with so many variations, and you truly could do this effect in so many different ways that no one would be able to pick up on the method because of how you performed it. Okay? Okay, so why does this crazy thing work? And why are there so many wrong proofs? Why is it hard to prove this thing? Okay, so I'm going to switch screens to step through that with you quickly. Okay, once again, I call this the face-up cards principle. I don't know if that's actually an established name or if I just made it up. It seemed like a reasonable name. So on the left, I have what I've indicated as a proof. And then over here on the right, I have an example with particular values that we can kind of follow along. Okay, so let's step through the general proof. And what I found with the proof here is the choice of notation is really, really helpful. So if you can choose names for the quantities, for the variables, that remind you of where the cards came from and whether they're up facing. Now, it is true that you could also include variable names that designate not only where the cards came from and whether they're down facing versus up facing. But I quickly discovered that you don't need to introduce those additional variables, and they just seem to increase the complexity of working through the proof. Okay, so I have chosen P here, letter P, to represent the number of cards in the packet. Okay, so in the examples that we've done so far, well, we've had 10 cards, right? In the very first example, we had 5 up-facing among the 10, and then 4 up-facing, if you go back to the very beginning of the video. But there's nothing sacred about 10. There really isn't. I mean, you can choose any number of cards that you like. You can flip any number of them face up, and then mix them to your heart's content. And then as long as you deal off the same number of cards as the number of face-up cards in the packet and flip those, these two halves will have the same number of up-facing cards. Okay, so letter P is the number of cards in the packet. So if you want to think 10 in our example. Now, a piece of U. I've chosen the subscript U to remind us that this variable is denoting the number of up-facing cards in the packet. Okay, now H is going to represent the number of cards in your hand that's like drawn from the packet. So these are the cards that eventually you're going to, quote, flip over. Like if you go back to the example of performing it under the table, right, where certain cards were counted off and then flipped over, H is referring to that number of cards that you've pushed over into your other hand. And then H sub U is the number of up-facing cards among the cards that you've pushed over into your hand. Now, if we assume, and this is the assumption that allows the proof to go through, if we assume that the number of cards that we're holding in our hand that we're going to flip over, if that number of cards is the same as the original number of up-facing cards in the starting packet, then the proof down here below is valid. It will work, okay? So just remember, we're always dealing off into our hand the same number of cards that are up-facing at the start, and then in a moment, we'll go ahead and look at what happens when you flip those over, okay? So here's a table. Okay, so on the far left, I have among the H cards in your hand, these are the ones you've kind of pushed over into your hand, maybe your left hand or right hand, depending on if you're left or right-handed. Okay, so, and then the second row here is the remaining cards, right? So you have a certain number that you've pushed over into one of your hands, and then you have the remaining the cards in the packet. So it's going to be P minus H. And those two together add up to P, right? So you get the whole packet size. Now, let's look at what's true for the number of up-facing cards before flipping your hand. We've already given a name to the number of up-facing cards among those. Okay, so just picture the cards in your hand that you've pushed over. You're just counting, how many of those cards are face up? Maybe there's 2 out of 5 or something. Okay, so that's HU. Now, among the remaining cards in the packet, how many of them are face up? Well, it's simply going to be the total number of face-up cards in the starting packet, P sub U minus H sub U. Well, remember our assumption. We're going to assume, and it is needed for all of this to work, that the number of cards in your hand will match the number of originally up-facing cards in the starting packet. If that's true, then we can replace P sub U here with H. You see that? So it's H minus H sub U. Okay. Now, what happens once we've flipped all of the cards in your hand? So the number of up-facing cards after flipping your hand. Well, what happens to the cards that are in your hand, right? So before you flip them, there's H sub U up-facing cards. Well, if you flip those over, the number of up-facing cards will now be the total number H, take away H sub U, because those are now going to be down-facing, right? The ones that were up-facing before flipping your hand will be down-facing once you flip your hand, right? So you'll get H minus H sub U. Okay, so that's going to be true for the cards in your hand. Now that you flip them, you're going to have this quantity of up-facing cards. Well, look at it. That's exactly the same quantity we got down here for the cards not in your hand. And the cards not in your hand weren't flipped from their current orientation. They were just left alone, right? So you're only flipping the ones that you're moving over into your other hand, that quantity being decided by how many up-facing cards there are in the starting packet, okay? And so this H minus HU just stays the same here. There's no change since these cards weren't flipped. And so down here, the equality of the values in the last column proves the conclusion of the face-up cards principle. So the fact that these two quantities are the same means that the two piles you've created are guaranteed to have the same number of up-facing cards. Okay, so that's the general proof for it. Okay. Now, if we want to look at a particular example, where we actually put values in, why don't we go ahead and do that, and I'll do it on the table as well. So I'm going to switch out the screen here for just a moment. Okay, for this example, we're going to assume we have 20 cards, 12 of which are face up. Okay, so that's just to check our numbers here. So maybe we have one face up there, a couple here. So that's 3, 4, 5, say 6, 7, 8, 9, 10, 11, and then we just need one more, 12. Okay, just mix them in. And as you know, these can be, this could have been arrived at by just throwing the cards into the air and letting them fall, right? We just had to pick specific values for the sake of this example to kind of step through the proof, right? So if I haven't made a mistake, we should have 20 cards total, 12 of which should be face up, okay? Now, we will, as you know, because we have 12 face up, we're going to be drawing a hand of 12 cards. Okay, now normally that can be drawn from anywhere. Well, for the sake of the example here, I think I wrote down, if you want to look at the write-up on the left, that we'll want 7 face-up cards among those 12. Okay, so we may have to move cards around to achieve that, so that we can follow these values out the proof here. So I'll go ahead and just count out 12 cards to begin with. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And just out of interest, let's see how many are face up. Looks like there's probably too many, not that many, too many. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we were wanting 7 of them. Okay, so we'll switch out this one for that one. Okay, so now we have a hand of 12 cards in which 7 of them are face up. That would leave the remaining face-up cards over here, which it would be 5 of them, because 7 plus 5 is 12. That was the total number of face-up cards at the beginning. Okay, and now we should be able to step through the particulars of the proof here, right? So we've achieved this here. So we have this number here of cards matches the total number of up-facing cards, which was 12. Okay, so that requirement's met. Okay, now among the 12 cards, quote, in your hand versus the remaining ones, so among these, before flipping the cards, we have 7 up-facing cards. Well, we know that already, right? Well, how many will we have after we flip our hand? So we have this packet of 12, 7 are face up. What's going to happen when you flip that packet? Well, the 5 that were face down will now be face up, right? So now you'll have 5 that are face up, which is what we have right here. Okay, that's in red. Now, what about these cards over here? The ones that aren't going to be flipped? Well, how many are there to begin with? Well, the quantity here plus the quantity here, which is 12, needs to add up to 20. Well, we have 8 cards then. So we have 8 cards. That's indicated down here. Okay, so the remaining cards not in our hand would be 8. Now, how many of these are guaranteed to be face up? Well, we've already noted that, right? It's going to have to be 5, because we started with 7 face-up cards here and 12 total, so that leaves 5 here, okay? So we get a 5 here, and then for the far right column, that value doesn't change, because these cards will not be switched in their orientation whatsoever. They're just left as is, okay? And so the equality of these two values at the end, 5 up facing here and 5 up facing here, confirms the conclusion of the face-up cards principle. Okay, so I don't know if that was helpful for some people to actually look at specific values or not, but so this is a most remarkable principle, and it has so many applications, and I may or may not turn this particular principle into a series. There's much that can be talked about. I probably could produce at least 5 videos based on just this one principle. But I don't know really what the interest will be for that, or whether I'll run out of steam in wanting to do that. But so we'll wait and see if I have additional videos that draw on this face-up cards principle. So I appreciate you watching, and certainly take a look at other videos on this channel. There's many videos dealing with a variety of mathematical card magic principles. So I hope you find others of interest, and if you've enjoyed this video, hit the like button, and if you haven't subscribed, please do so. Thank you again for watching.